Now, I'd like to give you a greater insight into the difference between conservative and non-conservative forces. So let me show you an example of the non-conservative force of friction. If I take this 500-gram block and slide it to the right, I did work to overcome the frictional force. Now remember, work is the process of converting energy from one form to another. So the work that I did really converted chemical potential energy, right? I burned calories in order to do that work. I converted chemical potential energy into thermal energy. The molecules of this desk are now vibrating a little bit faster. Well, what if sliding it back to the left slowed those molecules back down and returned chemical potential energy to my body? It doesn't work that way, right? Both on the outbound trip to the right and on the return trip, in both cases, the thermal energy went up. Now that's different than the conservative force of gravity. If I do work to lift this block up, I convert chemical potential energy, but not into wasted thermal energy. I convert it into gravitational potential energy that can be harnessed. In fact, if I let it go from here, instead of doing work against the force of gravity, gravity now does work on the block to return the energy back in another harnessable form of kinetic energy, energy of motion. So let's also talk about how conservative forces and non-conservative forces can be described as path independent or path dependent. So I'm going to displace this block overall a net displacement of 0. In other words, I'm going to move it away 50 centimeters, to the right 50 centimeters, back this way 50 centimeters, and to the left 50 centimeters. Its overall displacement is 0. It's back to where it started from. But the total amount of work that I had to do in that case was greater than if I move it forward 50, back 50. Both cases, a displacement of 0. But this path is different than this path. And so the amount of work done to overcome the force of friction absolutely depends on the path taken. However, what if instead of lifting this up 50 centimeters and allow it to fall down 50, what if I lifted it at an angle to a height of 50 centimeters? Well, I still did the same amount of work. All that matters, or at least the same amount of work against the force of gravity. Change in gravitational potential energy only depends on the vertical displacement. So if I get it to this height by moving along an angle, still if I drop it from here, it's going to give me just as much kinetic energy back as if I were to lift it straight up and drop it from there. So work done against non-conservative forces definitely depends on the path taken, but the changes in energy involved with conservative forces are path independent. So some examples that we have for conservative forces, once again, are gravity, the forces exerted by an ideal spring. In the next semester of study in electricity and magnetism, you'll find that electric fields exert conservative forces on charged objects. Non-conservative forces include friction, air resistance, and even the forces involved in deforming a material. You've probably taken a paper clip before, bent it back and forth. If you feel it, you can tell after a while it warms up a little bit with all of that bending. Thanks for watching.